Number one, today, more than 56 billion kilograms of hydrogen are produced globally each year. This amount is equal to what would be consumed by 200 million fuel cell electric vehicles. And global hydrogen production is forecast to grow 45% in the next 3 years to 81 billion kilograms. That's an NHA forecast. The point here is that hydrogen industry is already a huge industry. It's a global industry. It uses mature technology, and it has an outstanding safety record. Number two, a lot of hydrogen is used to make gasoline. About half of the global hydrogen production today is used in oil refineries. If this trend continues by 2011, this will equate to roughly 135 million fuel cell vehicles worth of hydrogen will be produced to make gasoline. That's 15% of the world's car park could be energized by this hydrogen. Now, I recognize it's being used for another purpose, but obviously it must be a cost-effective input to the production of gasoline, or it wouldn't be put into gasoline. The point here is that an enormous amount of hydrogen is already being produced by energy companies as an affordable and necessary input to the production of gasoline. And the irony is that as these companies work hard to perpetuate the petroleum economy, they're establishing significant capacity to help initiate the hydrogen economy. Number three, a large hydrogen production site exists today near almost every major city in the United States and Europe. This means large quantities of hydrogen are already available and produced close to where most Americans and Europeans live. Number four, numerous studies have shown that the near-term total cost per mile of hydrogen when fueling stations are well utilized could be equivalent to $2 to $3 per gallon gasoline. That's an untaxed number. Thus, at today's gasoline prices, hydrogen used in fuel cell vehicles at volume already appears to be cost competitive. Now, I understand station utilization is an important consideration. That's why we have to introduce the vehicles in tandem with the stations so that we can manage this transition. Number five, as more hydrogen becomes available for transportation, prices are projected to decrease further. The U.S. Department of Energy's long-term target cost for producing, distributing, and dispensing hydrogen is equivalent to $1 to $1.50 per gallon of gasoline, again untaxed. DOE has identified several pathways in its hydrogen roadmap with the potential to meet this target. Number six, several analyses have shown that the deployment of a fueling infrastructure is within our reach. Now, at GM, we did an estimate that with a network of 12,000 hydrogen stations in the 100 largest cities in the United States, and every 25 miles on all the freeways connecting these cities, now this means that hydrogen would be within 2 miles of 70% of the population in the United States, that we could get this kick-started. Now, similar results exist for Europe. Now, even if these stations cost $2 million each, which seems to be a reasonable number that with some maturing of the hydrogen station technology that we could get to, that's $24 billion. I know that's not pocket change, but in light of the overwhelming opportunity we're talking about, we think it's a very, very doable number. Put that in perspective. That's $80 per resident of the United States, $80 per capita. Now that's about 2 tanks full of gasoline per each citizen in the United States. So think about that. For 2 Phillips, we could potentially have an infrastructure out there that would allow us to get moving here with 70% of the people in the nation. Number 7, natural gas, electricity, and water are widely distributed in the U.S., making virtually any site a location where hydrogen could be produced. Initial studies suggest that distributed hydrogen production, either by natural gas or electrolysis, could be economically available, approaching a cost of $1.50 per gallon equivalent. So we don't see the infrastructure challenge necessarily as being one about pipelines and tankers and refineries and delivery trucks and stations. It may rather be one about appliances that we can reform natural gas efficiently and cost-effectively or electrolyze water. Number 8, to get started, natural gas is a good starting point. A 2% increase in the natural gas consumed in the United States would support the first 10 million fuel cell electric vehicles. These vehicles would reduce CO2 emissions by 50%. Natural gas is already a proven affordable source of hydrogen. at these refineries. It's about 60 cents per gallon equivalent to make the hydrogen. The point here is that this is a good place to start. It certainly is not the end game, but it's a way to get started that could make sense. Number 9, at the end of the day, we have to balance the vehicle and infrastructure growth, and concentrating the initial sales of our vehicles in specific geographic regions as the energy industry concentrates the growth of the infrastructure in those regions. A practical first step would be to focus this initially in 1 or 2 major metropolitan areas. And finally, number 10, as I stated before, this is an economically viable and doable challenge. The hydrogen infrastructure for automobiles will require a collective will by the energy suppliers, governments, and all of us need to have the courage to shape our destiny and take this infrastructure to the next level.